Hi, Chris Good here. Here's another one-way ANOVA problem, and let's read about this one. It's problem number 2 from the one-way ANOVA practice problems. It says a researcher is concerned about the level of knowledge possessed by university students regarding U.S. history. Students completed a high school senior level standardized U.S. history exam. Major for students was also recorded. Data in terms of percent correct is recorded below for 32 students. Compute the appropriate test for the data provided below. We're looking for significant differences among different majors on a U.S. history exam. And here are the scores. Let's go ahead and do all of our steps. Let's take the null hypothesis here that the mu for the first group is going to be equal to the mu for the second group, which is going to be equal to the mu for the third group. But we actually have a fourth group here, so mu 4 is the last one that we do. All right, so we've got 4 mu's. Step 2 is to state our alpha. We're going to use 0.05. And we'll need an F crit, but in order to do that, we need our degrees of freedom. I'm going to put a pin in that. Compute F. And the last step is to make a decision, and then we'll write our sentence. What do we need to do? Let's look up F crit first. In order to do that, we need the number of groups. So that's 4 groups, or we could just count the means that we've got. We also need to know the number of scores that we have. So I'm going to say equals count, and then I'm going to select all the different scores, and not including anything that's not a score, and that's 32. So we can compute degrees of freedom between treatments as k minus 1. We can do within treatments as n, whoops, n, click on the n value, minus k. Now, we can get total by adding between and within, or we can get total by taking n minus 1. You get the same number either way. So our F crit is going to be evaluated as 3 and 28 degrees of freedom between and within. Let's go to our F table and check it out. It's around here somewhere. There it is. Back to the top, entries in light face are critical values for 0.05. We have 3 degrees of freedom in the numerator because there's 4 groups, and we have 28 degrees of freedom in the denominator. So 2.95 is our critical value at 3 and 28 degrees of freedom. 2.95. F crit equals 2.95. Now, compute F. Okay, so we're going to need means, the average of all these scores. Good thing that we've got the same number in each group. That means we can use Tukey's if we need to. So we've got our means. Let's get our T's. It's the sum of all the scores in a group. Don't include the mean. That's not a score. That's a mean. We've got T squares. That's T squared. T squared, T squared, T squared, T squared. We've got n's, so we're going to count the scores in a group. T is the sum of the scores in a group. N is the count of the scores in a group. 8 in each group. Now we can do T squared divided by little n for each one of our groups. There's only one K. There's only one G, which is the sum of all the scores. And G squared is simply G squared. I think we've got everything that we need to do sum of squares between treatments. Let's make a little room here. Sum of squares between treatments is equal to the sum of our T squares over n minus, don't ever forget to do this, the quantity G squared over big N. And there we've got sum of squares between. We could compute mean square. I'm going to wait till we do the within treatment sum of squares. We're going to do it this way. I'm going to copy these labels so that I know what I'm doing here. We're going to do education deviations, business management deviations, behavioral social sciences deviations, and fine arts deviations. And compute the deviations. For education, it's the education score minus the education mean, and I'm going to hold that mean constant as I paste it down the column. For business management deviation, it's the management score minus the business management mean. Hold that mean constant as you paste it down the column. Let's repeat the same thing for behavioral social sciences. For its mean, using the dollar signs in front of both the column letter and the row number for the mean. And the last one that we do is fine arts score minus the fine arts mean. Hold that constant as we paste it on down the column. And now we just simply square those deviations. So this is going to be the education deviation squared, the business management deviation squared, the behavioral social sciences deviation squared, the fine arts deviation squared. You just say this is education deviation squared. When you paste that formula into all of the cells over here, it'll update everything so that everything that you calculated here is now squared over here. Works out nicely. Now we can get sum of squares within treatments. It's just the sum of all those squared deviations that you just did. Don't sum the deviations, sum the squared deviations, and then you'll get sum of squares correct. Total sums of squares then is the sum of these two things, and now we can compute the mean squares that we need as sum of squares over degrees of freedom between treatments, sum of squares over degrees of freedom within treatments. Now we can compute our F as between treatments divided by within treatments mean square. This F is very tiny. That's small. It's certainly smaller than 2.95, and so our decision is to fail to reject. Fail to reject, or retain the null. And the sentence would be something like, we, capital We, did not detect a significant difference in U.S. history score among the 4 majors. F of 3 and 28 degrees of freedom was not the F crit, it was 0.048 with P greater than our alpha. Okay, so we failed to reject. That means we don't have to do a post hoc test. You only do that when you find a significant difference among your means. We did not find one, so we don't need to know which differences are significant. None of them are. That's our conclusion. I do want to do one more thing here. I want to compute the grand mean, which we haven't done yet in these problems. It's the average of all the scores. Average of all the scores. And what we can do with this grand mean is to say, I'm going to copy these labels down here, just make a little bit of extra space. And these are going to be deviations from the grand mean this time. Business management, deviations from the grand mean. Behavioral social science, deviations from the grand mean. And fine arts, deviations from the grand mean. For each one of these, I'm going to say, take the education score, subtract the grand mean, and keep B20 constant. All right, let's look at that formula. This means from B2, education score 62, subtract B20. Now when I paste this on down for 8 rows and 4 columns across, I'm going to get deviations of every score from this same grand mean that appears in B20 down here, 55.375. That's the grand mean. So I'm going to remember that we have 8 scores for 4 groups, and I'm going to paste that into there. If we summed all these, we'd get 0, because that's what it adds up to. And I'm actually going to square these deviations, keeping track of them. And the reason I'm doing this is so I can find what the total sums of square is by calculating in a slightly different way. It's a slightly different way of doing total sums of squares. So if that equals this deviation squared, and I copy and paste, again, 8 rows for 4 columns, I get a whole bunch of numbers. Those should add up to this number. Let's see if it does. So I'm going to do total sums of squares over here, again, by summing, just to compare these two. Total sums of squares is going to be between plus within, but it should also be equal to the sum of the squared deviations of all these scores from the grand mean. Oh, and it is. I love it when the math works out. So either way you calculate this total, this is a good way to check your work to make sure that these two things add up to the correct total sums of squares. That's it for this problem. I'll see you on the next one.